So the next speaker is going to be Dr. Socorro Vázquez Campos. It's a pleasure for me to introduce Soco. We met a lot of years ago already, and she's group leader and area manager of the Human and Environmental Health and Safety at the group in the Circular Economy Department at LEITAT. She's one of the few experts in the field of nanosafety, nanotechnology, and full life cycle. She has been working for a long time on this topic, and she has been leading numerous national and international projects on it. She has been publishing a lot of papers and contributions to books, chapters, conferences, proceedings, and today she will present us her work on towards safe and sustainable by design nanomaterials life cycle considerations. So, Soco, the floor is yours.
Okay, good afternoon. And first of all, I want to start thanking the organizers for inviting me, and especially Neus, that we have been not seeing each other for a long time. So it's nice to be here, even though the audience is a small representation, but it's always nice to be again physically. So, continuing in the same area as Chiro was introducing already, now I'm going to talk about safe and sustainable by design, which is a term that is quite common now, that we talk about the safety from the early stages of the innovation and sustainability issues considered from the beginning. So I will go, oops, okay. So I will go first to define. So here I put that definition. There's no consensus definition for safe by design in nanotechnology, but of course this term has been already used for a long time. So one of consensus definition is that we define safe by design by including safety as at the earliest stage of any development in products and processes, and with the intention to keep and prevent the risks and ensure clean, healthy, and safe living environment. So we have that means that we have to minimize the risks and also identify them and address them as early as possible. And all the materials, substances, products, and processes in the production process should be intrinsically safe. So this should be the statements to follow if we want to follow this concept of safe by design. And what means, oh, sorry, I think I went too fast. What means initial steps, how to implement this, in which steps of the innovation process. So the industry normally follows these steps. So they go from an idea to a business case, and then to the development phase of the product or process. And then there is the launch of the product to the market, and is in contact already with consumers, society, and is out there for use by the consumers. So early stages in the innovation phase means that we should already consider safety when we have the idea. So the initial idea of developing a product, and it can be a nanomaterial, but it can be a product containing a nanomaterial, you already should think in what implications, in safety implications, should be considered. And considering, of course, the application of your product. So if the product will be applied different, for different applications, then you have to consider all the impacts that might have this product in the environment, in the human health, and all the activities that they will take place during the life cycle of that product. So safety is always considered in all the steps, but the safe by design concept is meant to be applicable at the beginning of the process. So what means considering or making this process taking into consideration the life cycle? So life cycle of a product means that we have to consider from all the materials that we use for the production of that product. Then manufacturing the final product also has some steps. Then the application of this product and the use by the consumers, and then the end of life. So also it's really important to know where this product will end up, landfill, incinerators, recyclability of that product. So all these are all the stages of the life cycle that you have to always take into consideration when you think about safety. So if you think how complex is to think about all that, and also how complex is a nanomaterial, and how complex is to include a nanomaterial into a product with the characteristics of the product, then this, it becomes really complex. And this is what we have been actually studying for many years since the nanosafety area started to do research. We start with materials, raw materials, and we start going into the life cycle and checking all the steps. So all the different exposures where the nanomaterials can impact either the workers or the consumers or the environment directly or indirectly. Then we have also the consumers, and that can be professionals or final consumers, so the society. And the exposure levels will be different depending on how much time you are in contact with these products that contain any nanomaterial. Then the workers, so this is, as shown in the previous talk, is one of the areas that has been more studied because it's really more concentrated in the occupational setting, so you are more accessible places to measure and to have control on the measurements. And then, of course, the end of life and recyclability of these stages are more difficult to monitor what happens there, and also less studies have been done on those exposures and releases from the nanomaterials. This is, for example, what I meant. This is an example of a polymeric nanomaterial, a product, polymeric nanocomposite, that is done by 3D printing. So what I meant before with the different life cycle stages, so here to produce the final piece that the people is using, you have to pass through the production of the nanomaterial with the characteristics you need. In this case, is anti-static parts. So you need particles that give this property to the final product. And there is, in this process of this production of nanoparticles, there's already quite some activity, so which we call it scenarios, exposure scenarios, where the potential workers can be exposed to this, to any potential releases and during the process of production. Then there is a manufacturing phase where you put these particles into the polymer to produce these parts. And then there is another series of activities that they take place in the manufacturing facilities that they also need to be safe. So you need to monitor also what happens there, and if the workers working there will be exposed to that. Then the second phase of the manufacturing is to 3D print the final piece, which is this example here. And there is another activity, some printing processes, post-processing, cleaning. And then the service life is when the customer already buys this and uses, and there is a lot of activities that the consumer can do with this that can be in contact with the consumer. And then the final end of life for these pieces that normally it follows one of these processes that they also generate some scenarios to potential exposures of nanomaterials. So all this is necessary then to do a mapping of all the potential emissions and releases along these life cycles of products, and to identify where these potential releases from these activities go into the either the environment or the workers or the consumers. So you have all these receptors, which is either the human or the environmental species that will be receiving all the release materials that are coming from all these activities that they take place along the life cycle. So this is what means to include the life cycle considerations. And then the community, the nanosafety community, then after studying and producing data, then we are also trying to see if the risk assessment process that normally is used for chemicals is possible to be applied for nanomaterials, which has this complexity and this all this data demanding that it needs to be included in a risk assessment process. So what we need is for quantifying the risks along the life cycle for a nanoproduct, we need to measure and to have data on all these steps, as I said, on the exposure side, but also what are the impacts in the different species, so the hazard of these release materials in all the stages. So we have, the risk is a balance between exposure and hazard. So we need to quantify the exposure and hazard to evaluate if we have potential risks in each of the life cycle stages. And then if the risk is identified, then we have to try to mitigate the risk or reduce the risks by applying any of the risk management strategies. So one of the risk management strategies that we are discussing is the safer by design. So if you design something safe from the beginning, then your risks are lowering or going down in the whole process. And then there's risk management measures that goes to exposure control, to waste management, and you have different possibilities to lower these risks and minimize the impact in the human health and in the environment. So for that, we've been analyzing which are the risk assessment tools available for out there for covering all the workers, the consumers, the environment. And then what we found is that most of the methods are focused on occupational human health, as Chiro was saying in the talk before. And most of them, they don't cover the environment, so the environmental impacts. And most of them are control banding, so you give some bands to control your risks. And then a few of them can be applied to nano-enabled products, but not all of them can cover this. So this is our quick overview of what happened. So then we developed a recent Guy Nano tool And this was under European project. And this tool includes all the phases of the risk assessment, focusing on environmental and human risk assessment, and allows different levels of data availability. So there is the possibility to use worst case if you don't have data, as Chiro was saying, that sometimes for some nanomaterials, the data is not available, so you have to go to worst cases. And when you have a lot of information about one nanomaterial, then also this tool allows you to include all these parameters, and then the risk assessment will be more realistic. And this tool is meant to be for risk assessment, estimating the risk assessment in a quantitative way. And it is also providing a flexible structure, as I show in the next slide, that will allow for further updates and further developments to be included in different parts. And here is what is the components of all this tool. Is a software-based tool, and it's divided in different parts that I show you more detail. So it includes all the description of the exposure scenarios. As I described before, there's a lot of exposure scenarios that maybe the companies are only interested in some of the exposure scenarios because they are producing only the nanomaterials. So you describe the exposure scenarios that you want to be assessing your risks on, and you don't need to go for the whole life cycle. But in some cases, you are interested in the whole life cycle. So you describe the scenarios, you define your nanomaterials, so the materials that are involved in your risk assessment. You have these modules that allows you to do that. And then you have the exposure and the hazard for evaluating the risks, which, as I said, provides all the models that are used for exposure assessment. It provides you also a possibility to include your measurements, your exposure measurements that you did in your own facilities. You can include the measurements done if you have them, or use the models. And then the hazard assessment is also based on all the testing that you have done on toxicological data from your materials, or if is available in any database, you can input into the tool and use it for the evaluation. And then it gives you an output with a quantitative risk assessment on human and environmental, depending on what are your scenarios that you want to cover. So this is a tool that is flexible, as I said, and this tool will allow us, as I will show later on, to be to apply and to be used for safe by design purposes. And going into the safe by design, so we are currently coordinating the project Sabina, and I will give you some overview of the project is running now for almost 2 years, so halfway we are. And the objective is to come up with a platform that is a guidance for the industry on how to include this safe by design concept from the design phase in their production, in their innovation process, and to guide them on which tools, which strategies they have to use to be safe or to produce something safe from the beginning. And we have, of course, 2 showing cases in the sectors of paints and 3D printing. So what is the idea behind this platform is that until now, as I said, the nanosafety community, we have been working on developing a lot of tools, models for exposure assessment, hazard assessment, risk assessment, and we have a lot of data produced in many of the materials. So all that needs to be, put in one place and help the industry to say, when do I use this? When do I have to go to this tool, to this model? Because I'm confused of so many things available in different parts and located in different documents and reports. So the idea behind Sabina is to provide this platform to guide the industry on saying, if you have your idea on introducing nanotechnology in your process and your products, then how to implement this safe by design concept from the beginning. So what means that is that we will have guidance on how to assess exposure, to assess hazard, to come up with identification of risks, and to give some safe by design solutions. So how to, which strategies I have to apply to make my material safer. And all that, it has to be balanced with the sustainability aspects and the cost aspects, because the industry has to make a balance on, I have to make my product functional. Of course, it has to be for the application I want. It has to be safe. It has to be lower costs compared to my competitor, and it has to be sustainable. All the activities I do, they have to be sustainable and not impacting the environment. So all that is a balance that we have to provide to the decision that the industry has to make if you provide all these parameters to balance them. So safety, costs, sustainability, and functionality. So the Sabina guidance platform is structured in two parts. So the part one is a screening phase, let's say, so that the industry can do in a quick screen, already know that if you go in the good or bad direction in terms of safety, on designing their products based on nanotechnology. So what we are actually in this first part of the tool or the platform, we will ask a few questions to the user that it has to input. So which is your material, which is your product you want to design. And then with this few information, we already have to give some warnings on if there is warnings on hazard or exposure of this material, and give some safety recommendations. And this is possible not for many of the materials because we don't have data enough to provide this information. And then what we do is, if we don't have information enough to give to orientate the industry at this step, we tell them to go to the second part, which is a more detailed assessment. That is the second part of the platform, in which we provide guidance on how to use different tools, different risk assessment tools, exposure, hazard, which ones to use in each case. And then there will be a possibility to identify their risks if they have provided this data, or if this data is in some of the databases available for nanotechnology. And then we have to also give some life cycle assessment and cost estimations to the providing guidance on which tools to use to estimate the sustainability, the costs. And then the industry make the decision of all these parameters, and decides if they want to apply some strategies to make it safer, or if they want to continue for their production because of costs or sustainability issues. So all this is under development in the project, and one of the core parts of the platform will be the Guide Nano tool that will be tailored to address the safe by design, for safe by design purposes. So we have the flexibility to modify all the modules that the Guide Nano tool has in terms of guiding in the most efficient way to the industry on which are the key testing strategies, which are the key models, the key exposure assessment tools that they need to follow to get identification of the risks. And this is also what we are trying to modify in the Guide Nano tool. And in terms of safe by design strategies, what we are trying to introduce into this platform is a guidance on how to reduce any safety or any risks identified in the hazard or in the exposure side. If the risks are identified, we have to provide some solutions or some strategies. So for example, if you have a particle that has the surface chemistry is the problem that produces hazardous species to impact in the hazard of human or environment, then we have to provide some strategies to modify this surface chemistry. And so we will give these solutions, but we always have to compensate that we don't give solutions that modify the technical function of the particle that the industry is looking for in their product. And also we have to identify that these physical chemical properties that are giving hazardous or risks, then they are not the key physical chemical properties that they give this technical function to the nanoparticle. So this is also a balance that we have, that we are trying to come up with this list of approaches and strategies to put available for the industry there. And in terms of sustainability, well, here is just a summary of what is life cycle assessment. It's one of the tools to assess the sustainability. So it's a tool that evaluates how a product or material affects the ecosystems and the human health, and the potential impacts that these products have throughout its life cycle. So this is a standardized tool already. And what we are trying to do for the platform of Sabina is to simplify this tool, to make it simple for the use of the industry and to tailor it for safe by design purposes, using as much as possible all the inputs that are coming from the risk assessment as well. And as you see, what we will be focusing on the simplification is to take into consideration the nanomaterial releases, which are the key things that we want to monitor for the impact in the environment, and then come up with all the effects that can have in the different environmental compartments, as is shown here. So the release and the emissions goes into the different compartments of the environment and damage the ecosystems. So this is a kind of tool that allows you to measure this and to take this into consideration on the whole life cycle. And in the terms of costs, so we also been analyzing what are the existing tools there for that normally are used for evaluating costs or assessing costs. And on all this evaluation, we actually found a few of them, and we will be focusing on using those to provide a simplified form of costs also in the platform for the industry to take considerations on how much cost is implementing this strategy that you are suggesting to us into our facilities and in the product development. So it's an indication and will be more or less an indication of how much or in which range of cost we are compared with the classical production. And so this is the last slide is about when this platform will be ready. So in next April, we will have the first release of the platform. So we will show how far we get in this platform. And then every year we will have some until the end of the project. So the next years, we will have this outcome of the development of the platform to get to the final one, and always with a stakeholder engagement activity aligned to these releases to be always covering the needs of the industry. So if the industry doesn't like our platform, we will have time to modify it and making it more useful for the industry. So the idea is that the industry uses this platform to for their purpose of Safe by Design. And so that is all I wanted to say, and thank you all and all the consortium of Sabina that is doing a hard work to get to this final goal. Okay, thank you very much.
Thank you very much, Soko, for your nice talk. And now it's time for questions. Do you have questions in the audience? If not, I have one. It is very interesting, this Sabina. Indeed, my question is it compiling the results from other platforms, or is it generating new meta information on the results that are obtained? Do you understand what I mean?
Yes, the idea, this call has been launched to actually not generating a new tool or new platform, but is to provide guidance to the industry. And the approaches are different. So we have 4 projects that are approaching the same topic. But the idea is always to help industry to implement this Safe by Design concept using what is already there. Because what we have to do now is we've been working in the nanosafety community before on producing and generating tools, data. So now is the time to use it, to make use of all this data and make sense, and also to help industry to use this data and say, okay, all the data that you produce, what is telling me?
But I guess that you're using artificial intelligence tools to extract this information, or you
no,
are...
it's the way is to analyze this, all this data and the tools that exist, and take those key elements of this.
Okay.
To tell the
industry. You are
so
extracting information to provide a more, let's say, processed information to the...
Exactly.
Okay.
So to use our expertise to process all this information in a more easy way for them to understand it.
Okay, no, I'm wondering to see what are the inputs and the outputs, no, that you are putting. So indeed, I assume that what you are going to put is a particle size, a particle composition, and some conditions, and you will extract a potential toxicity or potential risk assessment based on the different platforms that they are already.
Yes, based on already algorithms that they were developed for these calculations. But the algorithms is not that we build them new, but we use the key algorithms used for the calculations. But we will put it then in a way that, you know, these are the ones that you use for these purposes, and the other ones are for the other purposes. So they know why they are using this and why you're using.
Because I assume that these algorithms, they are covering different aspects, individual aspects.
Exactly. Because each of them were done for a purpose. And maybe that purpose is not what all the companies want, but I want maybe something else. So depending on their purpose, then you also guide them in the right direction, let's say.
Okay. Thank you very much, Soko.
Thank you.
Is there any question? If not, let's thank Soko again for her nice talk, and let's move to the next speaker.